Hey, what is up? Welcome to Radical Academy, and my name is Mike Wara, and in this video we'll be looking at electricity, and specifically we'll be discussing about how resistors can be connected. Okay, so behind me on the board you can see that we have two types of resistors connection, and these resistors connection, we are going to see the differences between when resistors are connected in parallel, when also resistors are connected also in series. Okay, now for those who are watching this video for the first time, if you are new to this channel, please don't forget to subscribe and like and share this video to your friends and families who you think that they also need this kind of information. Okay, so don't forget to subscribe so that whenever I post, we upload a new content to our channel, you'll be the first person to be notified that the Radical Academy has actually posted something on their channel. So don't forget to subscribe. Okay, so now there's a video that I did, I think 2 years ago, about electricity. I'll kind of link it up also in the bio so that you can also be able to watch what the video was about. But the video was of course about electricity. Okay, so now without wasting much of the time, let's now jump right into it. Okay, so we have to understand that resistors when you talk about resistors, right? When you're talking about resistors, we are talking about just some kind of a component, okay, that can actually resist current to flow. So this okay. So what we're supposed to understand is that resistance is a opposition to the flow of electric current. So when current is flowing in a conductor or in the wire, it's kind of get disturbed or experience some kind of a friction, and that kind of friction is what is normally observed to be as resistance. Okay, because not every electron or electrical charge within the wire or copper wire is being actually allowed to pass through. Okay, now when you're talking about connection of a series, that first of all we have to understand that when you're talking about series connection, we are going to have something like this, a simple circuit. Okay, so when you're dealing with resistors that are connected in a series, okay, I want you to understand is that what you can see, that these boxes, the two boxes, they're the one that do represent kind of theoretical resistors. Okay, so now we can actually name them as R1 and then also R2. So we can kind of keep on plugging in depending on how much of the resistors that we do have. Okay, so if we had more than two resistors, we can also put another one there, and then this will kind of make three resistors. Okay, so I want you to understand that we are going to restrict ourselves to just two resistors. Okay, but that doesn't mean that you can just end on two resistors. Okay, you can still have more than two resistors, okay, as many as 20, 100, depending on how complex the electrical appliance you're looking at is, okay. Now from there we have to understand that we have the batteries, or rather the cells, and let's just say this is 2 volts, okay, or maybe let me just say 3 volts, okay. And then we can say that this is 2 ohms, and then the other one is maybe 1 ohm, and then the other one is 1.5 ohms, okay. So the units of resistance, okay, the unit of resistance is the ohm, okay, which was discovered by one of the physicists, okay, George Simon Ohms, okay, is the guy who was actually understanding what resistance is and who came up with Ohm's law, okay. So this is how the circuit diagram looks like when resistors are connected in a series, okay. So please make sure that you understand the difference between a series connection and also the difference between also the resistors connected in parallel, okay. Now with that said, okay, and then we shall also have a simple diagram, okay, that's going to illustrate, for example, okay, let's have something like that. Okay. So now you can see on the diagram that on my left I've got also another circuit diagram, and this circuit diagram is different from the first diagram because that diagram also describes how resistors are connected in a parallel, okay. So we want to learn first of all the differences between resistors that are connected in series and that one which is also connected in a parallel, okay. So here's the thing, okay. So the differences normally are seen in the way that current is moving, okay. You can check it out, like for instance, I would say let's put the direction of current. Okay, so this is positive, negative. So this is current I. It is moving, and so the current is moving through the circuit, and we have the power supply right there, okay. So what I've done is I have actually indicated the direction of our current, okay. Now we have to understand that first of all, for a circuit to completely run, okay, kind of everything to be working properly and nicely without any fault, is that we need first of all the power supply. Now this is just a generalized kind of number that I picked. Of course, you can have something, a standard thing, okay? So 3 volts, and then resistor 1, resistor 2, resistor 3, okay? So even the numbering doesn't matter so much. This is just to help us which one is the first resistor, which one is the second, as well as the third resistor. And if we do understand that, then we can also, implicitly, explicitly assign them like 2 ohms, 1 ohm, and 1.5 ohms, okay? So now you can see that the difference is that when resistors are connected in a series, these components, okay, these electrical components that sits in the same kind of wire, okay, they are just in the same kind of wire, so there is no divergence, there is no current moving in 2 ways, okay? So as the current now keeps on going, okay, as the current keeps on going, it just passes on one single line where these resistors are connected, okay? So in a series connection, okay, in series connection, okay, series connection is that resistors are in the same line, okay, the same line. And then the other thing I want you to understand is that if you're given that this is let's say, for example, let's say the current they are passing is maybe, for example, 10 amps, okay? The current that is passing there is 10 amps, okay? So 10 amps passes at R3. So what that means is that at R3 it is going to be 10 amps, at R2 is going to be 10 amps, at R1 it is going to be 10 amps. The reason is simple, is that since the current is just passing in the same kind of a straight line, okay? So series means straight line, okay? So something like this, okay? So this line is more like a series, okay, in the same line. So we can have something like that, something like that, something like that, something like that, okay? So meaning whatever passes there passes also there, also passes there, also passes there, okay? It's because they are in the same line, okay? So they are kind of connected in the same line. And if that is understood now, so meaning current is the same, so current is the same at all points, okay? And that's one of the key thing about understanding resistance, okay? Current is the same at all points, okay? Wherever you try to find the current, on that points, the current is just still the same, and nothing is going to change. There is nothing that's going to give us any difference at all, unless otherwise we find something different other than what we have talked about, okay? Now let us move on to resistors that are connected in series, okay? I mean parallel, sorry. So you can see that there's a battery, the power source is 1.5, and then also we have 2 kind of resistance that are connected in different lines, okay? In different lines, and that's where the key thing is. That's where the difference is, okay? So you can see that this R1 is on top of this line, and then this R2 is down there. So it's like we have a single line on top, and then the other single line at the bottom, and then we have the connection there. We also have the connection, okay? Now, if you understand what I'm saying, is that as the current passes here, okay, you discover that since there is a 2-way in which the current can go to, okay, so like the current, when it reaches at this point, it can go this way, and then it can also go this way. Okay, so this kind of makes the current to have a different amount that is going to be registered at the other kind of resistance. Okay, resistance. So if we say at R2 we have, let's say for example, 1 amp. Okay, we have 1 amp, and then at R1 we might also have maybe 1.5 amps. Okay, so the idea is that in a parallel connection, the current takes different pathways. Okay, different pathways in order for it to be navigating within the circuit, or to be taking the power supply to the other component of the circuit, specifically the resistor. So the current kind of navigate in different pathways in order for it to just register that current to that particular resistance. Okay, so if that is understood, now what is the other thing about what are some of the differences? Okay, so you discover that in parallel current is not the same. So the current is not the same, then voltage is the same. Okay, the voltage is the same, and then the other stuff is that current takes more than one path. Okay, so the current takes more than one path, and by the way, that the small terminal there is a negative part, then the bigger terminal is a positive part. So the current moves from a positive, goes to the comes back to the negative. Okay, so we see how you can find the total resistance either for the circuit, for the resistors that are connected in series, as well as also for resistors that are connected in parallel. So you can see how you're going to find the resistors. Okay, so in series is that in series we are saying that the current just takes one way or one path. Okay, so the current just takes one path or one way. Okay, so what we're going to see is that we're going now to start applying the Ohms law, so that we are able to see now how we can really understand the proper application of the Ohms law when we just understand the differences between resistors that are connected in series and those that are connected in parallel. Okay, now with that said, let's now jump into the other stuff that I want to mention. Is that one more stuff, the difference that the difference is that also in a series, okay, about the voltage. So the voltage is different. Okay, so what we mean by that is that the voltage is different is that at this R3, sorry, the voltage will be different, and then at this one the voltage will be also different, and then also at R1 the voltage will be different, and then the opposite also happens in the parallel kind of a circuit, is that the resistor, the voltage is going to be the same, but what will be different is that in the parallel connection, the voltages are the same, the currents are different because it takes more than one pathway, okay, or just navigate in different pathways, whichever are there in that circuit. And then in this one, it just takes one path, okay. So this makes sense that the current will just be the same at each and every point that we might even be so interested to register how much current is going on or how much current is passing through by means of using an ammeter, okay, an instrument that you can use to measure the amount of current that is passing at a certain point within the circuit. Okay, with that said, now let's now jump into the calculations of circuit connections. Okay. Okay, so how to calculate total resistance? Total resistance either in a series or in parallel. Okay, so we start with series. Okay, we start with series. So in series, what you just do is, for example, you just say resistance R, and then you put underneath the T. Underneath the R, you put the T, which is just equal to, meaning how many resistors do you have? 1, 2, 3. So you say R1 plus R2 plus R3. So if there are more than those resistors, you can just keep on adding them, okay? It's just a matter of adding them, okay? So this is going to be 2 plus 1 plus 1.5. Okay, and this is going to be 3 plus 1.5. This is going to be just, is it 4.5? Okay, it's a 4.5 ohms. Okay, so then that's how you can just answer what is the total resistance, meaning the combined resistance, okay? The total effect of R1, R2, and R3 is just a matter of adding them together, and then you'll be able to get the 1.5, okay? Okay, so now that's how you can just find the total resistance in the series connection. So it's just a matter of adding